convert into hydrochloric acid medium and then do the plating. There, plating is going on. Okay, and then prepare the sample like this. This is the it's the clean sample, silver based, because polonium deposits on silver. Okay, so that's why we use silver. So you can prepare the sample, or we call it plating of chemical deposition of polonium on silver. This is sorry for disturbing, because the strength is very, there are only few. Okay. So some of you can come this side. So what we are demonstrating today is how to do prepare the sample for alpha spectrometry. So for demonstrating that, I have taken a soil sample. You see, this is a raw sample. We get the sample from the field. So now I have taken a soil sample. It could be a sediment sample, or it could be a sample from a biological, so for example, fish sample, or it could be, a vegetable sample. What we should do is, get the sample from the field, dry it at 110 degree to remove all the water content in it. How much to dry? So you have to dry it at least 24 hours and weigh it again and again. And the mass of that should be constant. Every time the weight you should get should be constant value. That shows that all the water has gone out. Okay. So this is a dried sample like that.
Save the sample.
Sieved. Yeah, dried and sieved. Yeah. It is not mandatory that you sieve. It depends on your applications. For example, certain applications like, for example, those who come from nuclear facilities, they want to do the dose assessment study. In that case, they don't prefer to sieve it, because if you sieve and take out your fraction, that fraction may contain higher activity. So they will be inferring higher dose. Okay. Whereas some of your application, like earth science or sedimentation rate measurement, it may require a certain fraction of the soil to be analyzed. Okay. In such cases, you can do the sieving. It is depends on the application. Here I think we have sieved sample. So we have taken a sieved sample, and this sieved sample of soil, we have to subject it to complete digestion. It is a destructive technique. Gamma spectrometry is a non-destructive technique. So here we digest the sample completely. How do you digest? We add strong acid, nitric acid, perchloric acid mixture, or nitric acid, hydrogen peroxide, and the digestion can be open air digestion, or it could be microwave digestion. You can see the microwave digestions also in the next room. We normally do the microwave digestion because there is no loss of sample at the time of during this digestion process. You may often see that when you do the digestion in the open air in a hot plate, there will be spurting. When there is a spurting, there is a sample lost. Whereas in the microwave digestion, it is digested at 100 bar. And there is nothing going out. Okay, so you get better recovery there. But there are advantages and disadvantages. Here in the open air digestion, you may take 10 gram of sample, you may take 20 gram of sample. But in the microwave digestion, in one Teflon bomb, you can take maximum 0.5 gram. So if you have 10 bombs, so you could get maximum 5 gram or even less than that. So it depends what exactly your application is. So if you want to study the trace elements, and if you want to subject the sample for, for example, ICP-MS, then microwave digestion is always better, because you want to avoid cross-contamination. You keep 3 samples in the hot plate, okay, and you are digesting. And when it spurts, a portion of this may fall on the other. So such cross contamination you want to avoid. So that's the reason you go for microwave digestion. We will show, if you are interested, we will do one microwave digestion here, tomorrow or day after. It is depending on your interest. So basically it is a total destruction of the sample. So whatever organic matter is there, carbon content is there, should be digested, should come into solution. So that is, for that we use strong acid, nitric acid, hydrogen peroxide mixture, or nitric acid plus perchloric acid, or if you want to digest the silica also present in that, then you go for HF. You take, instead of glass beaker, you take Teflon beaker. Take a Teflon beaker, and Teflon beaker untalla ಇಲ್ಲಿ ತಗೊಳ್ಳಿ ಒಂದು, ಇಲ್ಲೇ ಉಂಟಲ್ಲ ಅದು, 10 ಎಕ್ಸ್ಟ್ರಾ ಇರೋದು ಎಲ್ಲ ಅಲ್ಲೇ ಉಂಟಾ? You can take Teflon beaker also if you want to use hydrogen HF, hydrogen fluoride, because that is reactive to the glass. Okay, so that is the basic thing. So this is the raw sample. In this sample I have already added nitric acid. So, and now you, after you add nitric acid, you also put some hydrogen peroxide and you heat it. And this is the Teflon beaker, you see. So you should use Teflon beaker if you want to use HF. Okay. So you heat it and then add that acid mixture again, and continue that process maybe about 5 times, 6 times. Then you will see that all the organic matter gets destroyed, and you get a clear solution like this. Okay. So from here it should come here. Okay. Okay. You digest with nitric acid and perchloric acid or hydrogen peroxide or HF, whatever it may be, and then all the carbon, organic matter will be destroyed. The elements which are there in the sample will come to the solution. Okay. Now it is in nitric acid medium, is it not? But for the silver, for depositing the polonium onto the silver disc, we want it in hydrochloric acid, because nitric acid reacts with the silver. If you put silver into the HNO3 solution, within a minute it will disappear. Okay. So we don't want this sample to be in nitric acid medium, we want that to be in hydrochloric form. So what we do, once you digest the sample, then you convert into HCl medium, 0.5 normal HCl medium or 1 normal HCl medium. How you do? Nitric acid was there, you evaporate it, add concentrating nitric acid twice, then you add 0.5 normal HCl, 100 ml or 2 ml. This is 100 ml, 75 ml, whatever the volume you want. Okay. So now from this stage, it has come to this, and intermediate stage is there when it was digesting, and then from there I have converted into this stage. This is in hydrochloric form, 0.5 normal hydrochloric form. And this is the one set of sample, soil sample, and this you see the clear sample is phosphogypsum sample. There are 2 varieties of samples we have taken. These are all soil samples, digested. You get yellow color because there are many other elements, iron, ferric form it is present. Here it is phosphogypsum where there was no iron. So hence you will find that it is a clear. Okay. Whenever there is a higher organic matter content, you will get higher, greater color, dark color. So there was, these are the organic rich samples. These samples, phosphogypsum is a white powder. There was no organic material in it. So these are samples with no organic material. So that is the difference. So you may ask why there is a yellow color here, white color. Because it depends on the sample, which sample it is. So these are soil samples, these are phosphogypsum sample. Is it clear to you? Now it is in 0.5 normal HCl medium, right? Right. Now there is polonium. Whatever polonium is here has gone into the solution, or whatever any other element which are there here. Okay. Now this sample, this is the basic sample preparation. This sample you could take it to ICP-MS also if you want to determine the iron, nickel, copper, or manganese, magnesium, zinc, copper, whatever you want to do, you can subject the same thing to ICP-MS, or you can subject it to AS determination, whatever may be, whatever may be. So depending on your instrument. These are the basic step for the common step for any elemental determination in a sample.
Can I use those sample in LSC?
Huh?
Can I use those sample in liquid scintillation?
This one?
Yes.
Liquid scintillation, this sample should be miscible with your cocktail scintillator. Okay. If this is miscible with the cocktail, then you could use. Is it not, Arya? Yes. If it is not miscible, it's not. Yes.
Sir, at what stage we are adding polonium to note 9, sir?
Yes, we are adding that. So I am coming to back to that.
One more question. How much time will it take for the digestion?
It depends on the quantity of the mass of the sample you take. If you take, say, for example, 1 gram of sample, this digestion will be over by 24 hours in open air. And the same thing in the microwave digestion, this takes about 1 hour. Okay. But then I said there are, advantages and disadvantages. It depends on your application. If it is for only polonium determination, I would rather go for open digestion because I can take larger mass of the sample. If I want to go for ICP-MS, then I go for this microwave digestion because there I need a microgram of sample and I need minimal cross contamination. That's the thing. Right? Any doubt before that? Yeah. Now one important step we missed in the beginning itself, before we added this concentrated acid, is to add the tracer, polonium 209 tracer. Why tracer has to be added?
To determine the efficiency of the
Yeah, to get the efficiency. Polonium 209 or polonium 210, 210. They both, chemically both are same. Okay. It's only the one mass missing there. One is 209, other one is 2010. Both follow the chemical procedure. So, in order to determine what is the recovery of your polonium 210 of your method, we need to add a known activity of T09, polonium 209. Or the other alternative is you should take a reference material. IAEA gives polonium 210 reference material. You could digest a reference material and find out what is the recovery. But there also there is a problem. See, if you determine the efficient recovery, in one method, for one trial you may get 90%, for other method you may get 80%, the third one you may get 84%, and the fourth one you get 86%. There is always an error, is it not? Error in the measure, starting from the weighing of the sample and till the end measurement, taking the counts from the spectrum. There is always uncertainty associated. There are 4 or 5 important uncertainties. One is weighing, other one is recovery associated with that, and the third one is counting error involved in it. So, if you determine the efficiency for one sample, say for example, in a month I am analyzing 100 samples. Okay, today is December 10th, and till December 30, I am going to analyze another 100 samples. And you may ask, I take one reference material today and I determine the efficiency. But today you get that efficiency, 90% you may get. Tomorrow you take another batch of sample and the recovery in that can be only 84%. Same, it could be. It depends on, how long you digest and how long you plate, all those things. No method will give you exact value 90%. If you say 90%, no method will give you 90% in 100 analysis. You do 100 consecutive analysis, no method will give you 100 value, 90%. It will vary. And sometimes you may vary by 10%, 15%, we don't know, depending on the sample. It depends on the sample also. So, best thing is to do in the spectrometry is you add tracer for each and every sample, okay, so that you determine the recovery and efficiency for every sample. So, that gives you the exact value of the activity present. So, in the beginning itself what we do for the dry sample, we add tracer. We have tracer here which is polonium-219 spike we call. So, this has a known activity. I think it has got 4.5 dpm. I will give you the exact value of this. I think 4.5 or 4.8 dpm. So, we add 1 ml of this to this. Okay, 1 ml of this to this. Rashmi, 1 ml add ಮಾಡ್ತೀರಾ? ಯಾರು ಆಗ್ಬೋದು, ರಶ್ಮಿ or Bharat. But it is always important to note down. Normally when I was a student in the BSc, my teacher said you add accurately pipetted out 1 ml of sample. Okay. At that time it was okay. We used to do very methodically. 1 ml is 1 ml. You used to be, but we don't know. But when it comes to very low detection level thing, you think that it is 1 ml pipette. Okay. It could be 0.9, or it depends on the user. There could be a drop at the tip which may not have fallen onto that. Okay. Or you see the meniscus, for example. You may see like this, you may see like this. There could be different. So, it is always better, of course, you pipette out exactly, but it is always better to add the tracer on mass basis. So, what you do is you measure this in an electronic weight measure. Rashmi, Arya, take this and weigh the sample. Huh? So, it is always advisable, or it is always advised to add the tracer, or not only tracer, any sample you want to take for analysis on mass basis, not on volume basis, because volume basis there is larger uncertainty associated with that. So, you can see that how they do it. So, error associated in mass based measurement is minimal compared to volume based. ಇದು ದೊಡ್ಡ ದೊಡ್ಡ ಆಗ್ತಾ ಹೋಗ್ತಾ ಉಂಟಲ್ಲ, IRPಗಿಂತ ಮೊದಲು ಅದು ರಿಪೇರಿ ಮಾಡಿಸ್ಬಿಡೋದು. IRPಗಿಂತ ಮೊದಲು ಹೊರಗಡೆ ಒಂದು ಪೇಂಟ್ ಎಲ್ಲ ಮಾಡಿಸಿ ಒಳಗಡೆ IRP ಆದ ನಂತರ ಪೇಂಟ್ ಮಾಡಿಸುವ. So, you see that they are adding 1 ml of tracer, polonium-209 tracer, which has a half-life of about 122 plus or minus 5 years. So, you note down that, close madam amele. Aita. You
purchased from?
Huh?
Standard purchased from?
That is brought from USA.
Yes.
Yeah. So, these standards are available. Yeah, you can get Amersham or you could get Amercium, or there are many other companies. Yeah, we bought it from USA, and you can go for either NIST or Amercium, or there are few other French companies which gives its radionuclide standards. So this is very important. So you could add 1 ml, but then that 1 ml need not be 1 ml. It depends on the how accurate your pipette system is, how accurate that pipetted out goes into the sample. But this is the most accurate method where you can minimize the uncertainty associated with it. So we have added tracer now. Now do this sample, we have to add concentrated nitric acid and perchloric acid mixture. Okay, that is what you see here. Okay, right. So these samples which we have here, out of that 10, 8 or how many are there? 9. 9 out of 9, 7 have tracer plus polonium, 2 have only polonium, no tracer. So we wanted to demonstrate both of that. With tracer how the spectrum looks, and without tracer how the spectrum appear in the alpha spectrometer. So from this tracer plus sample, it has gone to this stage, then digested and converted into hydrochloric acid medium. These steps are very much clearly mentioned in the manual, is it not? Yeah. Now where are we in this manual? Yeah. We are here. We are here. 7. Yeah. We are at step number 7. Any doubt till this point? Correct? Now, what is the next step now? Yeah, that's what we see here now. You see? Rashmi, ಒಂದು ಸ್ಯಾಂಪಲ್ ಅನ್ನು ಪ್ಲೇಟಿಂಗ್ ಇಟ್ಬಿಡಿ ಅವ್ರ ಎದುರಿಗೆ. Now, meanwhile, what you should do, before the samples go for plating, what we should insert that is inside is this silver disc. Okay, because polonium reacts with silver here and forms silver chloride and deposits on that, chemical deposition. So here what you should do, you should take a silver disc. You can see here we have silver discs, many of them. These silver discs should be cleaned properly and polished and should be background counted. If you are using the silver disc again and the same disc again and again, so you should put it into chromic acid. If you put the silver disc, once plated silver disc onto the chromic acid, then whatever plated polonium is there will come to the solution. So this will remove all this chromic acid will remove all the polonium there. Then you have to polish it and then clean it with the double distilled water and ethyl alcohol, and you have to dry like this. Okay, these are the silver planchets which are ready to take for plating. And before we take it for plating, this ಏನು ಮಾಡಿದ್ರಿ ಒಂದನ್ನು ನಂಬರ್ ಬರಬೇಕು, ಗಮ್ ಟೇಪ್ ಹಾಕಬೇಕು. See this, when I place the silver disc onto this, the polonium which is there in the sample will present in all the sides of the disc. There are 2 main sides, up and down. If I place it like this, there will be one bottom side, one in top side. Polonium will deposit wherever silver is there. So we don't want, because alpha spectrometry is performed only in one side. Otherwise what you should do is, you should count it on both sides, side A and side B. Okay, and we don't want, because alpha spectrometry often takes weeks together. Very low activity samples in sedimentation studies, you may have to count it for 200,000 seconds. Okay, and you repeat it for one sample, it is 400,000 seconds. We don't want. We want to count only in one side. So for that what we do is, you see here, On one side they are putting polythene tape on the bottom side. See, they will show you because I have not put gloves. That's why they are handling it. See, one side they are putting polythene tape.
The numbered size we are putting.
Yeah. ಅದು ಸಿಕ್ತಮ್ಮ ಎಲೆಕ್ಟ್ರೋಪ್ಲೇಟಿಂಗ್ ನೆಟ್ ಇಲ್ವಾ? ಇಲ್ಲಿಟ್ರಿ ಹಾಗಾದ್ರೆ ಇರ್ಬೋದು ಎಲ್ಲೆಲ್ಲೋ ಒಂದ್ಸಲ ಎಲ್ಲ ಕ್ಲೀನ್ ಮಾಡ್ಬೇಕಮ್ಮ. ಒಂದ್ಸಲ ಕ್ಲೀನ್ ಮಾಡ್ಬೇಕು ಅದನ್ನು ಫುಲ್. ಇರ್ಬೋದು ಇಲ್ಲೆಲ್ಲೋ ಇರ್ಬೋದು, ಇದನ್ನು ತೆಗೆದ್ರೆ ಖಂಡಿತ ಸಿಗ್ತದೆ. ಅದೆಲ್ಲ ಎಂತ ಬುಕ್
ಅದಕ್ಕೆ ಓಲ್ಡ್ ಸ್ಯಾಂಪಲ್
ಅದೆಲ್ಲ ತೆಗಿಬೇಕು, ಎಲ್ಲ ತೆಗಿಬೇಕು ಅದನ್ನು. Okay, she has now pasted the polythene tape on one side. So because of that, now the polonium will not deposit on the other side. Okay. So now the plating which is going on there also we have put what is called gum tape.
Sir, one doubt, it may be there is a stupid mistake, doubt. Sir, that plastic
Will not, you know, it will not, it will is plastic will not react with the sample.
Okay.
It is very stable. Okay. And then we have to put the sample number, everything.
It's an acid, now it is
Nothing happens to the plastic. Polyethylene is now very, you know,
Resistant to-
we can withstand very strong acid. That's why, you know, you store acids in some of the plastic containers. Even, yeah, like that. So she has prepared the planchet now. You mark it, whatever it may be, way you want. You put your sample name. And now we go for plating. Yeah. So now you see when we go for plating, there is one more important step involved here. You see that, you know, I said, you know, this is the phosphogism sample, this is the soil sample. Soil sample, there is, you know, iron is the most abundant sample, is it? Abundant element in the universe. So there is iron which is in the ferric form. Okay. That ferric form will intervene with the silver plating, silver this polonium plating. Along with the polonium, iron will also deposit. Then what will happen? Your silver disc will turn out black. Okay, there will be iron coating. So if you have an iron coating also with the polonium, that will give you distorted spectra. Spectrum will not be clean. You should always get a very clean peak. So we don't want that, you know, distorted spectra, and for that we want to reduce the ferric ions into ferrous form. Okay. For that what we do is we add ascorbic acid. Yeah. So first we put a magnetic bead like this. So we put a bead stirrer, magnetic stirrer. So whenever you do the radiochemical analysis, it is extremely important to ensure that each and every step you do should be very clean, because there is always a possibility of cross contamination, because you are measuring extremely low levels. A small contamination will give you result bias 50%. Okay, so we should always avoid that. I'll rotate ಮಾಡಿ first. Slow. And you rotate it slowly, you see, magnetic bead. Now she will put ascorbic acid, and you ferric will reduce into, yeah.
How much quantity, sir?
That you will see when it stirs, you should get a colorless solution. Yeah, that yellow color will go. See, you see that it is now become, yeah, you see, almost colorless. You can see that.
Sir, in phosphogypsum sample, we don't need,
Huh?
need to add ascorbic acid.
Pardon?
In phosphogypsum sample, we
No,
don't.
We always add, because even if there is some iron content, ferric form, that should be reduced. It is not that it is clean, there is no minimal iron, but even we want to avoid all those things. You see now all of them has, all color has gone. She will add some more on the half speed Kanta. Dissolve agli. Let it dissolve.
So one question that is, why are we keeping this phosphogypsum sample?
To demonstrate you some spectrum, that's all.
No, means one is sample and another is phosphogypsum.
This is also sample. This is soil sample. This is phosphorus sample. Both are samples. I am giving it two varieties of samples. Or if you wish, you can get some leaves from outside and bring it. No problem.
So I was thinking,
Or you
does
can
it
go to
have
market
any
and get some fish sample. We can do that.
Sir,
So there will be, instead of two, now there will be one leaf sample, one fish sample.
sir, what is the thickness of that silver disc? Sir?
Huh?
Thickness of that silver disc?
Silver disc thickness, I think, few fraction of a millimeter. We give the dimension of all those things. Yeah. So silver disc dimension is not a big deal, the issue, because you could prepare slightly bigger, because every time you polish, a layer goes off. Yeah. So if you have a plan to use the same disc again and again, but of course, if you use it for high activity measurement, it is always advisable not to use it again, because in every plating, the background will go, one or two counts increase you will find. So it is always better not to go for use a silver disc which is used for active samples. But for normal background samples, you can always, in that case, even if the sample is, the silver disc is thick, there is no issue. Plating is only on the top. So it all depends on what is the thickness of the plated sample.
That is the matter.
That is the important thing. That sample, plated sample should not be thick, because alpha can be very easily stopped. Okay, that's why we want to avoid the iron, other cross interfering element. Previously, we used to do it at 95 degrees centigrade. This. Then, if it is 95 degrees centigrade, the efficiency of plating is higher. Say you get about 95%. But here you may get efficiency of about 70–80%, depending on the sample. But then this gives you a much cleaner sample, prepared sample. You will, at the end of the day, see this sample plating was going on for 24 hours almost. So you see that silver disc as good as new one. Whereas if it were to be in the 95-degree temperature, many other elements would have sampled, that would have given a black color. In that case, that source preparation is not good enough. That, you get the spectrum distorted. You see, now it is almost all color is gone now. Slightly, some color is remaining, that is not an issue. Now, she will introduce the silver disc. Yeah. Only this face which has been pasted with the gum tape should go down, and the other one should face up. That's all.
ಅನಸ್ವರ ಮತ್ತೆ ಪೇರೆಂಟ್ ಬಂದಿರುತ್ತೆ.
ಯಾರು?
ಅನಸ್ವರ ಲಾಸ್ಟ್ ಇಯರ್ ಸೆಕೆಂಡ್ ಇಯರ್ ಸ್ಟೂಡೆಂಟ್ ಬಿಟ್ಟು ಮಿಡ್ಲಲ್ಲಿ ಸೆಕೆಂಡ್ ಇಯರ್ ಮೆಡಿಕಲ್ ಫಿಸಿಕ್ಸ್ ಸ್ಟೂಡೆಂಟ್ ಬಿಟ್ಟು ಹುಷಾರಿಲ್ಲ ಅಂದ್ರೆ ಹುಷಾರಿಲ್ಲ ಅಂತ ಕೇರಳದ ಅನಸ್ವರ ತುಂಬ ಸಲ ಕಾಲೇಜ್
ಬಂದಿರು ಮಾಸ್ಕ್ ಕಟ್ಕೊಂಡು ಹೋಗ್ಲಿಕ್ಕೆ ಅಂದ್ರೆ
ಅಲ್ಲೇ ಕೆಳಗಿರುತ್ತೆ ಬೇಕು
ಮಾಸ್ಕ್ ಕಟ್ಕೊಂಡು ಹೋಗ್ಲಿಕ್ಕೆ ಅಷ್ಟೇ. ಆಯ್ತಮ್ಮ? ಹಾಂ, ಉಲ್ಟಾಯ್ತಾ? ಹಾಂ, ದೇ ಆರ್ ಎಕ್ಸ್ಪರ್ಟ್. ಯಾ, ದೇ ಆರ್ ಟ್ರೈನ್ಡ್ ಥೊರೋಲಿ. ಸ್ವಲ್ಪ ಸ್ಲೋ ಮಾಡಮ್ಮ. And that bead should rotate very slowly. So this sample we have kept now, we are preparing it today. Tomorrow, today exactly you have to note down the time, because for all the samples you should note down when the sample was collected, okay? When the sample was taken for digestion, that is important. and when the sample was plated. Now the date ಮತ್ತು time. Because if you count this sample, this same planchet, say for example after 1 month, considerable amount of polonium might decay. So you have to do a decay correction. That's what Dr. Roy was telling. You saw decay correction. You were showing the graph, no? So you should do the decay correction for that. ಅದಕ್ಕೆ ಡೇಟ್ ಮತ್ತು ಟೈಮ್ ಹಾಕಮ್ಮ. ಹಾಂ ಹಾಕಿದ್ದೀರಾ? ಹಾಂ ಆ ಡೇಟು ಟೈಮ್ ಬರೆದ್ಬಿಡಿ, ಅವ್ರಿಗೆ ತೋರಿಸ್ಬೇಕಲ್ಲ ಕರೆಕ್ಟ್. ಸೊ ಒಂದಿಗೆ ಅಲ್ಲಿ ತಗೊಂಡಿದ್ದೀರಲ್ಲ? ಓಕೆ. This was plating was going on since yesterday evening. So this 24-hour will complete today around 5:30. Today at 5:30 we'll take out this. We will put it for alpha spectrometry. This needs another 24 hours. This will be ready for counting tomorrow at same time. So tomorrow we'll remove this and we'll put it for alpha spectrometry. And one sample which is already finished has gone there for alpha spectrometry. That will serve for your demonstration for you today. This will serve for the demonstration for tomorrow's batch. This will for day after batch. Okay? 48. And meanwhile they will be plating the other 2 samples also with tracer and without tracer. Suppose if you want to do the measurement, there is another, I said, one is spectrometry, other one is bulk counting using zinc sulfide counting system. If you add tracer and already existing polymer, then will you be able to count it with the bulk counter?
It will also add the tracer.
Huh?
It will also add the tracer.
Yeah. So the counts you get will be from both.
Yes, that is a gross counting.
Yeah, gross counting, because it gives counts from both. It doesn't distinguish between
Distinguish the elements.
isotopes. Whatever alpha is there, it will give you. So you will not be able to get the efficiency. Okay. So that's why spectrometry is advantageous. You could, in one sample, you add the tracer, you get the recovery and the counting efficiency for that particular sample. That is the advantage if you add tracer. Okay. Is it clear? Yeah. Any questions on this so far? If there is no questions, we go for spectrometry now. What is the time now? Tea ready there? Tea kudu hogodu. Any doubt? Any questions? ನೀವು ಅದು ಇಲ್ಲಾಂದರೆ ಕೆಳಗೆ ಆಲ್ಫಾ ಸ್ಪೆಕ್ಟ್ರೋಮೆಟ್ರಿಗೆ ಹೋಗಿ ಇದು ತೆಗಿಬೇಕಲ್ಲ. ಎಂಥದ್ದು 24 hours.
ಸರ್ 48 ಅಂದ್ರಲ್ಲ ಸರ್?
24 hours.
ಈಗ 48 hours ಅಂದ್ರಲ್ಲ ಸರ್?
48 hours ಇಲ್ಲ, 24 hours. Did I say 48 hours?
No,
24 hours. 24 hours.
After 24 hours,
You will be removing this.
and
It is expected that after 24 hours, this plating will be complete. Yeah. So you may get about 75 to 80% of plating.
Okay.
So it is optimized.
In another way we can do. So
Pardon?
in our lab we are doing like that. We are increasing the concentration with the operation.
That's what I am telling you. You heat it at 95 degree.
Okay.
You do it, plating at in a hot condition, plating at room temperature.
Room temperature.
This is the reason I am telling. If you do the plating in 95 degree,
Instructions.
then you at the end you see that the plate is black.
Yes,
Yeah.
completely bad.
Yeah, yeah. So then your spectrum will be, you will not get a clean spectrum. Here you see here in the spectrum, you can come here, see. This is now plating is going on for 24 hours. Even now the planchet is as good as.
Because of that color it will not be the problem.
Color, there will be problem. Because that black color is also a coating. You will see the resolution difference between this and other normal. Definitely there will be difference.
In our lab we are following that.
Okay.
Petroleum on that.
Yeah. That is electroplating.
Electroplating.
That is electroplating.
Yes.
Yeah. This is normal chemical deposition. Electroplating, there is a electroplating unit separate. I show it to you tomorrow. There is a electroplating unit where you take the sample, on the bottom you fix a disc and you put sample over that and you supply voltage. So that is electroplating. This is chemical deposition. There is also two methods. One is the normal chemical deposition method and the other one is electroplating.
Following, we are following this.
Same. This is enough. Yeah. If you want to do uranium thorium analysis, and then your disc will be either stainless steel or nickel. Yeah.
Stainless steel or nickel.
Nickel. Yeah, it depends on the element which you are analyzing. For some elements it is nickel, some elements it is stainless steel. For polonium it is silver. Right. And you could also use platinum dish. Yeah. Yeah. But for all the electroplating, you should always use platinum electrode. We have platinum electrode as well as this plating unit. They will locate it today. We'll get it tomorrow. Okay. So this is the one main difference we are following. Plating in room condition, because this gives much better spectrum. Okay. Okay. Huh? Yeah. I said, I demonstrated the polonium because in alpha spectrometry, that is the easiest radionuclide to be subject for radiochemical analysis and then do the alpha spectrometry. Because if you take uranium and thorium, their sample filtration itself takes 3 to 4 days. You have to pass it through anion, cation exchange column. We can, that is easy. All you need is a column, Dawes column. That's all. We could do it, but nowadays we don't do it because majority of those work are done with gamma spectrum. Yeah. Because uranium you can use 1001 protectum peak or 93.5 you peak and like that. And thorium, of course, you can do directly through actinium. Right? So if there is no doubt, we go down, and meanwhile on the way we see the micro digestion.